All right, everybody. Okay, so let's take a look at this thing that I just gave you. We have relations and functions that we're talking about today. I know that you know what these are, at least I hope. I can't ever seem to find my pencil. There it is. Yes and no.
Should we do this in algebra too?
Yes.
I don't think so. Oh, wait.
All right, everybody. Okay, you with me? All right, so we have relations are simply sets of ordered pairs showing a correspondence between two quantities. You are, I don't know why those are brackets, those should be smooth parentheses. So we can show a relation one of several ways as an ordered pair in a table, a graph, or in an equation, okay? So that's old news. What you probably have learned at some point, maybe you never really got very good at it though. We're looking at domain and range. So domain is the set of all input values X taken by the independent variable. In other words, its domain is all the values of X that you can put into an equation that wouldn't make the equation break. So for example, if you had X minus 4 in the denominator, you couldn't have a positive 4. It would give you a 0 in the denominator. Things would break. So 4 would be excluded from the domain of that equation. Okay, we're going to talk about that at great length probably tomorrow, I believe. Tomorrow and Wednesday, actually. Okay, so more to come on that. Range is all your Y values that the graph produces. Okay. Now, what is a function? A function is when we take a relation, a set of ordered pairs, where every element in the domain is assigned to exactly one element of the range. So in other words, if you plug in a value for X, one and only one answer comes out for Y. That's what determines if something is a function or not. So when I say, hey, when you work 6 hours, how much money do you get paid? If you get $10 an hour, you would say, I get $60. It would not be a function if I said, hey, when you work 6 hours, how much money do you get paid? And you have multiple answers for that. That would no longer represent a function because one value for X is now going to two different answers in one. That's what we're looking for. We actually don't care if the other way is true. If Y is repeated, that's not a big deal. Or I'm sorry, if one X value gives me multiple Y's, that's a big deal. If one Y value gives me multiple X's, that's not a big deal. So for example, if I ask you your age is, what are you guys, 15, 16? 17? Wow. Say you're 16. You only have one age at a time. You can't be 16 and 26 at the same time, unless you are living in a parallel universe or something. Right? However, could more than one person be 16? Of course. Right? So I'm going to have lots of repeats there, but your age, you would only have one value that comes out.
So there could be like multiple X values and then one Y value?
As long as every X value that you plug in only gives you one Y value back out. It doesn't matter if multiple X values give the same Y value back out, but as long as each individual X value only has one answer that comes out. Okay, oh, and there it is. Put a big star. If you got a highlighter, that would be a good thing to highlight. Each X value only has one Y value. So how can we tell if equations are functions? Let's flip to the next page and find out. You probably remember one of the ways. If you are given a graph, those are the easiest because you can simply perform the vertical line test. Do you remember the vertical line test?
Yes, I do.
Good. Those are super easy if you know how to do it. All you have to do is, let's just take a look down at the bottom. You can read those words up there if you want to. I'm going to take a vertical line and I'm going to pass it through. See, they already have one drawn. You pass it through all along your graph. If it ever hits more than once, it is not a function. If it only ever hits once at a time, then yeah, it's a function. So you can see this one is a function because it never hits a vertical line more than once. See that? Now, let's look at the not a function one, and you can see very clearly, ding, 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 right away, you have one X value that's producing two different Y values. That is not allowed. This is not a function. It has failed the vertical line test. Does that make sense?
Yes.
Okay. So we love the vertical line test, but in order to do it, you have to have a graph. If you don't have a graph, well, you're going to have to do something else. So let's see. Algebraically, we can check to see if something is a function or not. We are simply going to solve for y in terms of x, determine whether each input x is mapped to a single output y. So let's check out the two examples that are done for us below. So I'm going to cover this up and pretend that we don't see this yet. So we're given just this, 3x plus 2y equals 5. So I need to solve for y in terms of x. So let's do that. 3x plus 2y equals 5. I want to get y by itself. Let's minus 3x. 2y equals negative 3x plus 5. Divide by 2, divide by 2. If you want, you could turn that, I'll turn it into a decimal. Negative 1.5x plus 2.5. So now I can ask myself, okay, when I plug in a value for x, how many answers for y are going to come out? Jake?
One.
Just one. No matter what you plug in for x. I could plug in 0. I can plug in 100. I can plug in negative 9. I can plug in 0.25. It doesn't matter what I plug in. No matter what I plug in for x, we'll only get one answer back out for y. So this thing, yes, it's a function. Yay, yes, function. Let's look over here at this one. I know you already know the answer, but pretend I didn't know it yet. So I want to do the same thing. I want to solve this equation for y. X squared plus y squared equals 7. Minus the x squared. And now what do I need to do to get rid of a square? I need to take a square root. And what did we just say when we were going over the test? When I take a square root, Jake, you need plus and minus. You need both roots. Anytime you write the square root sign in the problem, and I need to square root both sides, I need positive and negative square root of all this business. So now check this out. If I plug in, let's just use an easy number. Let's plug in 0 for x. I get the square root of 7, but I need both roots, positive square root of 7 and negative square root of 7. I plugged in one number for x, but two answers came back out. So is that a function? No, that is not a function. Does that make sense? Okay, so not a function, as you already knew, because it was already there. But now we are sure. Okay, cool. So function notation, we already talked about this recently with our linear modeling we did in the last chapter. If an equation represents a function, you can replace y with f of x. So we talked about this, how, and it sort of goes down here. That letter f, or whatever it is, that's just the name that we're giving the function. It's just assigning it a name so that I can talk about it more easily, especially if I have multiple functions, right? If I have 4 or 5 different functions, it gets confusing which one you're referring to. That's why we name them. So I call one F, I call one G, I call one H, and so on. And then I can quickly talk about whichever one I want. So that's all that is. And then, so if you read it, the function named F evaluated at X in this case, whatever is in parentheses, that's what you're going to evaluate the function at. So we could replace that with a number. We could replace that with an expression. I would just take whatever is inside those parentheses and replace the variable in the problem with whatever is inside of those parentheses. Make sense? Okay, so let's try some. I think on the back it just says evaluating a function. So we're going to write some together. So hold on, I picked special ones that I wanted to do. Okay, so we're going to write 3 functions across the top, and then we're going to do a whole bunch of problems. So we're going to have f of x be 3x minus 4. We're going to have g of x be negative x squared, written just like that, plus 6. And we will have h of x as the absolute value of x minus 1. So take a moment and copy those 3. We're going to start off easy and then we're going to turn it up a notch. You ready, spaghetti? Anybody having spaghetti tonight? Yeah.
Sounds good.
If you make it, I'm sure you could have it.
That's work.
So, do you remember if I just write that, do you know what to do from here?
Yes.
Oh, go ahead, try it. If you don't worry, I'll explain in just a minute. So I gave you 3 functions, f, g, and h, and now in number 1, I'm asking what f of negative 7 would be. I'll take an answer if anybody thinks they have it. Go ahead, Katie. I agree. So where in the world is negative 25 coming from? Right here. F tells you which of the 3 functions you're using. So in this case, I'm just using the f function. And I just want to replace the variable, in this case, x, with whatever is inside the parentheses. So I literally just, instead of writing an x, I'm going to write in a negative 7. So I have 3 times a negative 7 minus 4. So if you evaluate that, you get negative 21 minus 4. So yes, f of negative 7 is in fact negative 25. And you're done. You don't keep going. F is not a variable. You're not solving for f. That's just the name of the function. So function notation is a little bit different, but I know you guys have seen this before. So hopefully now that you've had a little refresher, you're good to go. All right, let's try this one. Second practice one. Find g of 3 for me, would you? I have a feeling I'm going to get 2 answers for this. Some of you will get one answer, some of you will get another. Okay, Braylon, tell me yours.
I got negative 3.
Did you get the same? Did anybody get a different answer besides negative 3? Evan?
I got 1.
1. Any other ones?
Oh wait, I got negative 3.
Negative 3. Did anybody get 15? Okay, I knew there'd be those 2 answers for sure. So let's talk about what you want to get here. it is written like this note right here, that chunk, what it means is to square the x and then take its opposite. That is not the same thing as negative x squared. If I wanted you to square negative x, I'd have to put negative x in parentheses and put the square on the outside. When it's written like that, that means square the x, then take its negative. So when I go and I replace x with a 3, if I do this correctly, I'm supposed to square the 3 and then take its opposite. So that's going to be a negative 9 plus 6. That's where the negative 3 is coming from. And it is correct. Negative 3 is right. So now I ask you for our third one, find g of negative 1. See if you can figure that one out. I have a feeling I'm going to be between two answers again. Braylon, what's yours?
I got 5.
5. 5. Jake, 5. Did anybody get 7? I know you did. You just don't want to admit it to me. 5 is correct. If you got 7, you're making the same mistake again. So let's take a look. You have negative. Now I need to replace the x with negative 1. That's how you should have written it. Now it's up to us to evaluate it correctly. So let's see. This, when it's written this way, I'm always doing order of operations, right? Parentheses, there's nothing to do inside the parentheses, but exponents come next. So you're doing the number negative 1 squared. Negative 1 times negative 1 is positive 1. But this now tells me to take its opposite. So that is negative 1 plus 6. That's how we ended up at 5. If you got 7, I don't know. Sometimes kids, you see minus a negative, so you think it's plus positive. You're not wrong, but you are wrong when there's an exponent involved, because exponent has to come first. So g, the function g evaluated at negative 1, we should get a positive 5. Okay, let's make it a little trickier now, shall we? All right, yeah, let's do this. What happens if I do something like h of b? Yeah, what in the world are you going to do with this? Huh? H of b. So this one, I don't have a number here, right? I'm going to take whatever's inside the parentheses and I'm going to replace the variable with whatever's in there. It just so happens that this time it's not a number. I'm just swapping out one variable for another. It's basically what's happening here. So I'm going to take away the x and I'm going to substitute in a b. Whatever is inside the parentheses right here gets dumped in place of the variable in my function. So this literally would just be b minus 1, absolute value. That's it. That's as far as you can go. I just thought of one I don't have in my example, so I'm going to try and squeeze in another one. What if I did something like this? Oh, I would need another letter.
Pardon the interruption. Please dismiss the golf team at this time. Again, please dismiss the golf team for a match at this time. Thank
Any
you.
golfers? Me too. I would love to know how to golf. I've done mini golf one time. You don't have to write this one down, but just imagine, say I had another function, let's say m. M of x was x squared plus x. and I wanted you to find m of 3, you're going to replace, anytime you see the variable, they both get replaced with 3. So this would be 3 squared plus 3. Okay, so if your original function has multiple variables, it doesn't matter. They all get replaced with whatever is inside the parentheses. Okay, my next example to do, let's try this one. What if I asked you to do f of 3 minus h of 2? Huh. Give that one a shot. You have an answer?
4.
Ooh, 4. Anybody else get 4? Yes? Oh, good. Good, because that is correct. So to do this, I have 2 different functions that I'm concerned about right now. I'm going to pop a 3 into the f, get an answer. I'm going to pop a 2 into the h, get an answer, and then I will subtract those 2 from each other. So f of 3 means I'm going to do 3 times 3 minus 4. So that's just 9 minus 4 is 5, right? And then kind of over here, I'll do h of 2. Let's see. So that would be absolute value of 2 minus 1. So isn't that just 1? So 5 minus 1. Yes, I get that 4. Okay, easy enough? Okay, let's see how you feel about this one. What if I asked you to do f of x plus 3? Really, you have an answer?
3x minus 4.
I got the same as part of that. Then I have a different at the end. Lisa?
Oh,
3x plus 5.
Yeah.
that's what I meant.
Okay. Yeah. So 3x plus 5 is correct for our final answer. So let's figure out where that comes from. So f tells me I'm using the f function. I'm going to go up to my f function, and then I'm just going to write whatever the function is. But instead of writing the variable, I write whatever is inside the parentheses. So instead of writing 3x minus 4, I write 3, not times x, times everything that's in here, x plus 3 minus 4. See that? It is the same f function. I've just swapped out the variable for whatever is inside the parentheses here. And now I can just simplify this. I get 3x plus 9 minus 4, and that's where the 3x plus 5 comes in at the end. I get lazy on the left-hand side, but all right, now dig deep. You may not have even learned this notation before. I'm not sure. We're going to find out right now. Does anybody know what in the world to do if I give you this? Do you know what that notation even means? What? Oh, foggy. It does kind of spell fog. You know what to do?
Is that when you do like shear 4, salt of your 4, and then you plug that number into like.
You're 100% right. This notation can also be written another way. You can also write it like this, f of g of 4. So these two things are the same. So you kind of need to be comfortable with both ways of writing this because you never know what form it's going to be presented to you in. but they mean the same thing. All right, that little tiny O isn't really an O at all. It's not, it's kind of an operator. It's telling you, hey, this symbol, if you will, means whatever the second one is here, whatever one is closer to this, you're gonna plug into this one first, get an answer, and then plug into that one. It's a little bit easier to follow here, because here you kind of, just like with PEMDAS, right? When we're doing parentheses, we start on the innermost parentheses or work our way out. So this kind of lays it out for you a little bit easier. This kind of tells you, all right, take 4, plug it into the G, and then you're going to take that answer and then plug it into the F. All right, so the order matters, and I do need you to be familiar with both. So you would really start with the G function, plugging in for 4, and then get an answer, plug it into F. So go ahead and try it. Plug 4 into G, get your answer, and then take that answer and put it into F. Anybody have an answer? Final answer, Jake? I agree. Let's see where this came from if you didn't quite get it. So again, we're going to start with G of 4. So that's going to be negative and then a 4 squared plus 6. So make sure you're evaluating that correctly. That would be a negative 16 plus 6 or a negative 10. Okay, so that's my answer for that. And now I take negative 10 and I put it into F. So now do F of negative 10. Whatever that answer is goes into F. Okay, so that's 3 times negative 10 minus 4. And there is our final answer. Oh, I'm sorry. For F, little tiny O, G of 4. Okay, now you try this one. Try G of H of 2. Who's got the final answer? Raylan, go ahead. 5. Agreed. Where? Well, first, let me also show you, if you're going to write this in the other notation, what letter comes first if I want to write it the other way? Yeah, G and then a little O and then an H of 2. So again, those two mean the exact same thing. So be familiar with the notation either way. So no matter which way you're going to do it, you have to start with H of 2. So that would be absolute value of 2 minus 1. So yes, that's just 1. Great. And now we're going to do G of 1. So I take that answer and I stick it into the G. So negative 1 and then squared plus 6. And evaluating that correctly, you do in fact get 5. So there's my final answer for G of H of 2. Okay, one more example problem and then we're done. Try this one for me. Okay, we're going to do hog of 3x. It's not really no, of course. So H of G of x, of 3x, sorry. Try that. Okay. Anybody confident in this answer? Mackenzie, go ahead. 9x squared plus 5? I have something different written down. But let's investigate. So let's find g of 3x first. So that would be now negative, and then I want to replace the variable with whatever's inside the parentheses. So it would look like that plus 6. Is that part okay with everybody? All right, let's evaluate this. So I'm going to do 3x squared and then take its opposite. So that's going to be a negative 9x squared. Agreed or not agreed? Agreed? Yeah? Okay. Negative 9x squared. And then I still have this plus 6 hanging out. I can't go any further than that, right? I don't have like terms. So that's it for g of 3x. Agreed? Okay. Now I'm going to take that answer and I'm going to plug it into h. So I'm going to do h of negative 9x squared plus 6. So I'm taking that answer and I'm going to stick it in right there. So let's see. I'm going to take my h function, which is the absolute value of x minus 1. So I'll have absolute value. Instead of writing x, I write everything that's in the parentheses. Negative 9x squared plus 6, and then I have a minus 1. I can simplify that a little bit. I can do 6 minus 1. But I claim you're done here. I say you can't go any further. Why? Why can't I just say if it's a negative 9 in there, wouldn't its absolute value just be 9? No, because I'm not just multiplying here. If it were just a negative 9x squared in there and there wasn't this plus 5, I could do that. I could pull them apart and I could take the absolute value of each one separately. But because this is a binomial, I don't know, I'd have to add the 5 first. So I can't go any further than this. That's my answer. So there is h of g of 3x. Does that make sense? Okay. All righty. You ready to try some on your own? The enthusiasm. I love it. Oh my gosh. You guys. All right, let me get this up for you. Let me hole punch. Go so fast and make sure you sign out. Put an accurate time. Don't vandalize. Take this down there. Okay. One, two, 3, 4, 5. There you are. Okay, let me stop this.
Are we finishing this whole thing?